This is a brief voiceover PowerPoint that will review multiple baseline logic, although most of you appear to have understood this based on test results. A significant number, I think, are still struggling. So I do want to go over, using the same graph as appears on the test, the logic, the internal logic that makes a multiple baseline design an internally valid design. Okay, first, we're going to break it down student by student in this graph. This is a multiple baseline across subjects. 3 students were the subjects. And by the way, in subsequent slides, when you see something that says S1 or S2 or S3, they're referring to the subjects. The red area here represents a prediction, an area prediction of where the baseline data would be if it just continued. The logic is that the best prediction of future behavior is past behavior. So in this case, subject 1 baseline is a relatively level and not terribly variable data series, and we would predict if we did nothing, it would just continue as it was, and the data points would fall somewhere in or around the red box. The phase line, the first phase line, the only one we're really interested in, the intervention phase line, that shows when the intervention was applied. And you can see in this case that rather than continuing on its baseline path, the intervention resulted in a change. So here's the situation as it stands, just looking at these data. There's a possibility of a relationship between the presence of an intervention and reduced behavior in this case. We can't say for sure because there's many other things, many other confounding variables that could have caused this change. In other words, could have caused this deviation from what we predict. So we're going to have to verify our original prediction is the initial thing. Let's look at the next graph, which shows the first 2 subjects. As before, the red boxes show the prediction, the area of where we think the data would be for subject 1 and subject 2 if there were no intervention. So that's our prediction. And remember, we've already shown that for subject 1, when the intervention was present, the behavior was consistently lower. The blue arrow shows how we can verify that prediction. We're going to verify the prediction about subject 1 by looking at subject 2's baseline. And the blue arrow shows the part of subject 2's baseline that occurred after the intervention with subject 1 occurred. So it shows that the logic would be that we're going to infer, since nothing changed for subject 2, because intervention wasn't applied to subject 2, that verifies the prediction for subject 1. Subject 1, the prediction was in the red area for subject 1. In subject 2, the prediction was in the red area. And the actual data at the time of the intervention for subject 1 shows that subject 2 didn't change. Now, there's a phase line showing the intervention for subject 2. There's the red arrow there. And for subject 2, even though we predicted that subject 2's behavior wouldn't change, when we intervened, in fact, it did. That red arrow also represents a replication of the effect of the intervention on another person. So now we have 2 subjects, both of whom we've predicted from baseline what would happen if nothing were different, and both of whom, as soon as we applied intervention, we see a change. Further, we have more faith now that our prediction about what would happen without intervention has been verified. Subject 2 didn't change even when subject 1 was changing. So subject 2 only changed when the intervention was applied. So now we have 1 replication of the intervention effect, and we have 1 verification. So let's take a look now with all the subjects there, because this shows the complexity of the multiple baseline design. Now let's take a look at all the subjects. We see subject 3 there, student 3. And we can see that student 3's baseline continued even after we had intervened with subject 1 and 2. The blue arrow there on the last data series there, the bottom one, that's the behavior of subject 3 when there was an intervention for subject 1. In other words, that baseline for subject 3 still did not change, and this again, it provides a logical verification that if we don't do anything, that's our prediction, the baseline data would remain the same. The yellow arrow now also provides a verification of the prediction for subject 2, because even though we intervened with subject 2, nothing happened to subject 3. Only when we intervene with subject 3 did we see the behavior change. And that red arrow shows that we now have a second replication of our effect. So the logic is we've got two replications of the fact that whenever we intervene, behavior goes down, and we verified our prediction that if we didn't do anything, the baselines would not change. This is the idea behind a multiple baseline. We have to make comparisons within each data series, so we look to see what happens between baseline and treatment, and there's a change. And in order to verify our prediction, we have to also make comparisons between data series. For prediction about subject 1's behavior at baseline, we verify it twice, with subject 2 and subject 3. Those are the blue arrows. For the prediction about subject 2, we verify it again with just one subject, that will be subject 3. Now, we clearly are not going to verify our prediction about subject 3, but the logic here is we don't need to anymore. We have enough evidence to say that there is a functional relationship between treatment and behavior change. And that's the purpose of any kind of research design, is to be able to make that kind of assertion about a functional relationship between treatment and behavior change, and to rule out confounding variables. So we've ruled out a number of things that could have been happening simultaneously with subject 1 or subject 2 by looking at the continuing baselines as shown by the blue and yellow arrows. So with a multiple baseline, typically speaking, we have at least 3 different data series, in this case subjects. It could be behaviors or settings. Those are illustrated in your textbook. And we have a system that still allows us to verify predictions about what would happen if nothing was done, and to also replicate the effects. In other words, to have strong evidence that it is in fact the treatment and not something else that caused these changes. Let's summarize again. Here. 3 predictions of no change in baseline. If nothing were changed, data would continue at the same level. This prediction is verified twice, by the subject 2 baseline for the subject 1 prediction, by the subject 3 baseline for both subject 1 and subject 2. This provides strong evidence that our prediction in fact was accurate. And we have 2 applications of the actual effect. So we did intervene, and at the point of intervention, in both cases, we got a replication of our effects. No ineffective intervention, behavior stays the same all the way through. In other words, if intervention didn't do anything, the subject's behaviors would remain the same as baseline. In fact, there was a change at the point of intervention. So we have prediction, verification, and replication. And we have what's called an internally valid design. Now we still don't have, as we talked about in the textbook and in my other voiceover PowerPoint, still don't necessarily have external validity that we can say this would generalize to completely many other subjects. But now we have evidence for 3 subjects. External validity is, for applied behavior analysis research designs, requires us to replicate the study a number of times. And we're not going to talk about that now. We'll talk about that in fall of next year if you take the research class, or whenever you take the research class. So hopefully this clarifies a little bit the diagram on the test, and reinforces the notion that was discussed in your text in the previous video about baseline logic and verification, replication, and prediction.